why they're important, Musharif. You know why. How did you get the A?
Okay.
Please. I only have so much energy. You should save it for really hard questions. If you use up all my energy, then I can't help you when you really need it. Okay. Open up your notebooks. We'll continue now. Latent heat. Do you remember what slide we finished on?
Yeah, the example of 1 kilogram and from 0 to 1.
Yes. We calculated that, didn't we?
Yeah.
Okay. You saw Connell's email?
No.
Oh, okay. Are you sure?
Why did he mention me in the email?
Were you on time this morning?
Just today, just for today.
No, remember 2 weeks ago the bus was late.
It's like 5 minutes and when I arrived I saw you.
I know.
Yeah.
No, Musharif, you're not a problem. It's the others who are a problem. Right, Adnan? What? Oh, I'm sure you don't have a problem. I'm saying I'm having a problem with the 9 o'clock classes, in that there's usually only one student there at 9 o'clock. This morning there were 0. And if I'm honest, the thing that annoys me the most is not that people aren't there at 9 o'clock, it's that people don't cover what they miss, because then when I look at my YouTube channel later that day, I can see the video still has 0 views, which means, of course...
But I think the view is not right.
No, I think it is.
I watched the video like 3 or 4 times, and I saw the...
Yeah, but maybe...
Like
yeah, but I can see more because it's my account. You know?
So you know what is the real number?
Yes. Yeah. Anyway, the problem for me, I don't care if you're there or not at 9 o'clock, because I'll still get paid, and I'll just sit there drinking coffee. But the problem is for me that people aren't studying what they're missing because the videos aren't being watched. This will mean bad grades at the end of the year. This is my worry. If you get good grades at the end of the year and you never came to class, that's great. I don't have to do any work and I still get paid. It's the grades I'm worried about.
But if I didn't come?
Well, I can't really say if you don't come, because there's an immigration problem if you don't.
Yeah, so it'd be great if you say so.
Yeah.
I will leave this class.
The problem I have is just with the grades. I just worry about what grades people will get, that's all. Okay, anyways, we did one example last time. So let's see if there's another example. Here we go. Okay, if you can write this one down, please, and then I'll do it. Musharif!
Yeah.
Please write this down. Thank you.
Today is the Valentine Day.
I know it is.
I want to show some. This year is not fair. Like we spend the ding dong.
Good news for you, Musharif. It only gets worse each year. Gets less fair.
Yeah. You didn't have holiday since we came.
I'm trying to prepare you for life.
That even if you don't study at holiday, you still like have the stress in your head. I swear.
Yeah.
You just stressed about finally next week.
Don't worry, I'm sure you'll find some time to relax.
Yeah.
It won't be 7 days of stress.
More.
Okay. Did you write this down?
No. I'm not. Don't try too fast. I'm here. Stand like you can.
Yeah, go a bit slower.
Yeah.
Give him a shriek a break here, would you?
You write like you are in bed.
Got that?
Solution to 10.
10. This is a typical exam question. You'll need the table from last time. So what's happening here is you have 200 grams of water and 10 grams of ice. Is it 10 grams?
Yes.
Yeah. And they're in thermal equilibrium. What does thermal equilibrium mean?
Same temperature.
So what temperature are they at?
0.
Why?
Because it's ice.
0 is the only temperature possible for water and ice to be at the same time. So the temperature is 0. And then later, when the ice melts, the temperature is at 10. And it's still 2 kilograms of water and formerly 10 kilograms of formerly ice. So we want to know how much energy we need to do this, to go from here to here. Okay? So the first thing is the amount of energy you need will be the energy the water needs plus the energy that the ice needs. And this energy is coming in from like a, I don't know, heater or something like this. What is the water doing? Well, the water has just gone from 0 to 10, so that's just the the MC delta theta. But just be careful, what's the ice doing?
Changing state.
Firstly, it changes state, and then secondly, it increases in temperature as well. This is for the ice and this is for the water.
The changing state is ML?
Yeah, we did this last time.
Yeah.
So,
Without temperature.
yeah. So it's 0.2 times 4181 times 10 plus 0.01. I'll have to look up what it is for ice. Plus 0.01, 4181, 10. Can you tell me the latent heat of fusion, please?
The ice is like water.
It becomes water.
That is 2000.
You mean 343?
The latent heat of fusion?
For fusion water, 334 kilogram.
334 kilo.
Yeah.
It's a big number. Okay, can you hit that in on your calculator and tell me what you get? What am I doing? Should be something like, I don't know,
2 million.
million? I don't think it'll be as much as million.
One, two, one, 2, 0.
12100.
No, 2, 0.
Hang on, say that again. 1,
2, 1, 2, 0,
point
1.
120, no, 12.1 kilojoules. Got that?
But why there is ML, why there is MC just for ice, I mean?
For ice,
Yeah.
first it is solid, then it is liquid.
Yeah.
That's the reason for this. Then it goes
How
from,
did you know it's changing?
if the temperature
Only.
if the temperature is 10 at the end, it has to change.
Yeah, I know. But how did you know it changes state without changing that temperature?
But it does change the temperature. That's why I have this. So first it becomes liquid, then it gets warmer.
There is ML.
Yeah,
ML is from ice to liquid at the same temperature.
yeah.
How did you know it's there from ice?
It says equilibrium.
It has to, because if it starts at 0 and finishes at 10, it can't still be ice. It has to become liquid water.
There is changing temperature.
Yes, that's why this is here.
So where is the not changing temperature?
Here. ml.
Yeah, but
This is to change the state. And then this is when the ice becomes water and gets warmer. And then this here is just the water that gets warmer. The water gets warmer, that's that one. The ice changes state and then gets warmer. So this is like, and then gets warmer. Is it okay? Are you sure? I don't know. Do I trust you?
yeah.
Good. Okay, you wrote this down? Yes. Okay. So what's he has problem? He didn't get house keys or something?
Yeah. He couldn't go to the room. I didn't understand.
Did he get a new accommodation or something?
Yeah, he went to Montrose.
That's out in
Near
UCD, isn't it? It's one of the student halls, is it? Is it a student accommodation?
Yeah. A lot of people from there here.
Yeah. Okay. Continue. Okay, great. Here's another one I'll do. I actually have a few examples to do. Okay, if you can write this one down. So why weren't you home last night?
I wasn't.
Why weren't you on campus last night?
No, I was.
So then why the heck were you late this morning?
Yeah, I think no reason. Because Michelle said, oh, I want to do the work. I was like, yeah.
You live on campus and you were half an hour late. So that means you woke up.
15 minutes late.
I know it was more than 15, for sure.
20.
We're talking closer to 25 than we are. Yeah.
No,
About 20, around 20.
Oh yeah, around 20.
No,
Maximum
it's
20,
20.
22, something. I'm sure.
I was sending Isabel an email at the time, so I can just check the time the email was sent at, and minus 2 minutes from it. Anyways, no matter. We agreed that it was more than 15,
Yeah.
for sure. So that means you woke up after 9 o'clock.
No, what's
So then why were you late? Doing your hair, was it? Don't worry, if you come to class smelly, it won't offend me. I much care that you're on time.
What is the maximum time?
What does it matter? There's only 4 of us, so, I mean, what can I do? I can't say, don't come to class if you're late, because then it will just be me sitting there for 2 hours. Really, it's 15 minutes, you know. I should have marked both of you absent this morning, but I marked you in because you're the only 2 there. But if it's more than 15 minutes late, I'm supposed to mark you absent, you know. I marked you present this morning, but like I said, if there were other students there at 9 o'clock and you came in at 9:30, I probably would have marked you absent then. But it's because no one else was there. It's because your classmates also have trouble with 9 o'clock.
And also because we arrive at the same time.
Yeah, that too. Okay. Did you write this down? I think I worry more about your grades than you do. Would that be right? No? You do worry? Oh, good. Good. That's the first step then. Alright, okay. Alright. Let's have a look at this one. This question. Oh dear. I'm dying here. This question was an exam question a couple of years ago. So what happens is you mix some ice to some water to cool the water down from 15 to 5, and you want to know how much ice. So you can kind of picture this is like a Coca-Cola or something, because there's 330 grams, which is the size of a can of Coke. So this is kind of like room temperature, you know, roughly. So the idea is, how much ice do you need to put in to bring it from 15 to 5? Do you know? To cool it down. So what's happening here, you've got your cold glass of water, well, kind of cold, and its temperature is 15 Celsius and it's 0.33 kilograms. Then you have your ice. Now, did I say this in the question? Yeah, ice, and its temperature is 0, and its mass, we don't know, we'll call it X kilograms. Is that okay so far? Now, what happens when you mix the ice with the water? Well, the ice will get warmer or colder? Warmer. And the water? Colder. The energy which is lost by the water is equal to the energy gained by the ice.
Gained by ice?
Yeah, because the ice is warming up.
Yeah.
The ice will go from 0 to 5, whereas the water will go from 15 to 5. So, let's work out this here. This will be M C delta theta. What's delta theta? 10. Now, what is happening with the ice? Well, firstly it changes state. X L 333 000. And then after it changes state, it will warm from 0 to 5. M C delta theta. So, you could say 0.33 times 4181. Now, what's in common here? And guys, wait, I won't scroll down, I promise. What's in common here and here? So, look. Okay. I can take the x out, and then I can divide by this. So, Adnan, all you need to type in is this fraction. Let me open up my calculator since I'll need it.
So 0.3301 multiplied by 4181
Multiplied by 10 all over 334000 plus 4181 times 5. Let's see what we get.
So 20,905.
It's a lot of ice. It should be just a number like 0.01. No, I convert these into kilograms. So your number should be in kilograms.
0.330 multiplied by 4181 multiplied by 10.
Yeah.
All divided by 0. All divided by 33400
Yeah.
plus 4181 multiplied by 5.
But I can do it right now myself.
0.254.
This is what you should type. So what's that? About 39 grams of ice. About 30. So that's roughly 38.9 grams of ice. A reasonable number, wouldn't you say? Got it? Yeah. Yeah. Okay. Mishri?
Yeah.
Right. Here you go. If you can write this one down, please. No, don't. No,
Why?
Mishri, it's good for your English.
I want to buy it.
What do you speak when you go home with your aunt and uncle? Arabic or English?
Yeah, Arabic. What do you mean by my aunt? I don't know.
Oh, sorry, my mistake. Your sister, what do you speak?
Arabic.
Arabic, yeah. So
If
this,
you talk English in home, they will tell you about.
yeah, exactly. So in class, I'm telling you, more English. More English is better. And when you go home, you should say, but sister, my teacher said I should speak more English. Mr. Stephen, he can call you and explain. Or you can just show her this video.
If she has your number, I will be in trouble. Do you think your English, like you, all the days of the student with simple English, and when you go home, you find it like you forget? Not actually forget, but you find in your brain a lot of.
You know, to be fair, Sharif, the English I'm speaking during the day is not that simple. You know, I don't make it too simple when I'm talking in class. I just maybe would use less expressions. You know what I mean? Less sayings, less idioms. You know? Idioms are like expressions that don't translate well. For example, do you know the expression at the end of the day?
Yeah.
What does it mean?
It's not actually at the
It's not actually at the end of the day. In the end. Yeah. So I try not to use these during the day because I know they'll be confusing.
I can't use in Arabic things that these.
Expressions?
Yeah.
Really?
I can't, yeah.
Yeah. There's a lot of these in English, a lot.
You can.
And you know, it's funny, but two places where these come from, I wonder if you know, what's the most common source for all these English expressions, these idioms? One of them is Shakespeare. You know Shakespeare? Yeah. And the other one's the Bible as well. So I'd imagine for the Bible one, there's probably some translation in the Quran for the similar stories, you know. So I imagine the Bible ones probably translate okay, but I don't think the Shakespeare ones would translate so well. You know what I mean? Yeah.
But I think Arabic loves Shakespeare.
Really?
Yeah.
Really? Oh, so maybe it will translate well then.
I don't think.
No? I didn't know this. So you have to do Shakespeare in school?
Me, no.
No.
In English class.
In English class, yeah. Very good.
Shall I
Is it
compare
literature?
the-
Very good, that's the one, yes.
Is it literature or
So,
something? Like story or
yeah, English. When you get this one, then it's all English.
I think it's all story.
Yeah. Plays, poems,
And
stories.
He added a number of words to English. Like
Yes, he did, very good.
Many.
Many words.
Yeah.
You got that? Nearly. Now, Miss look at this new word you learned for cup. Calorimeter.
This is a cup. I thought it's divided like a meter.
I know it looks like it. Yes. It's basically just a cup. But it's a cup that you use to measure energy. So that's why the word meter's in it.
That's what I thought. I thought it's for temperature.
And you see the word calor, C-A-L-O-R? It's an old English word for energy. So,
Calorie.
yes, exactly. So it's like energy measurer, i.e. a cup. Got that?
I mean,
Tell me, is there a story in the Quran about writing that appears on the wall? Or not?
I don't know.
That writing appears on the wall.
Just they woke up one day and so.
Yeah, something like this. No?
I don't think so.
I know, it's one of the expressions I like in English. It says the writing's on the wall, and it just means what's going to happen is going to happen. I didn't know if you had the story in the Quran, you know. It's like from one of the prophets, I don't remember who, but there was a message on the wall about what will happen, you know, like a prediction. So I just think it's a nice expression. I don't know if you've heard it before.
What's happening?
Basically, there's nothing you can do about it. It's going to happen. I think it's a nice expression. I didn't know if you had it in the Quran. You don't know this story?
We have like, but not like in the world, like we saw that believe that God before creating anything, we created a pen, and he made the
Interesting.
pen write all the things that will happen, like
I see. So is there some expression in Arabic that kind of uses this idea?
Yeah, same idea, yeah, we have.
What's the expression? How would it translate?
the
قدر الله وما شاء فعل.
no, it's not like just on the side, like before we write in this pen we write in pen, like
Yeah.
you have to make it the pen with the brush.
Yeah, I know
You have
this
to
pen.
wait 2 days like before you will use it because it will dry. You won't
Ah.
dry.
So what's the expression? What's the
Yeah,
Arabic?
dry.
The paper is dried.
Yeah.
I see. So this
There's
means
no change.
no change. Very good. This is the same as the writings on the wall. So in Arabic, the paper has dried.
Yeah.
I like that one too.
But I don't think anyone will know.
If I say it in English,
Yeah.
we'll get it started. Yeah. We'll start using it then. Okay. What is this?
Just that also.
That one's a little too hard for me.
Yeah.
I'll stick with the paper has dried. Okay, you wrote this down? Let's have a look at it. This one is, as you can see, quite hard. What happens is you have water and you put in a copper cup, and the cup is 25 grams. So what is happening, you have the cup, and the cup is 0.025 kilograms, and you put in the water. I should do it in blue, I suppose. And the water is 0.250 kilograms. But we don't know the temperature. X Celsius for both of them. The only thing we know is that when we heat it up with a 5.5 kilowatt electric kettle, it takes 2 minutes for all the water to turn into steam. Do you understand what's happening?
Yeah.
So if you think about this, the first thing we should work out,
The work.
yeah, the work done. So you have power is work over time. So work is power multiplied by time, which is 5.5 times 120, which is Oh, multiply by 1,000 as well.
No, it's not 1,000. Yeah.
Yeah, it is. Yeah, so what do you get?
6640.
4,
No, 0000.
0000 joules. Yeah? Now, where has this energy gone? Well, it's done two things. It's heated the copper up from what temperature? X. And what's the final temperature of the copper? If you think about it.
If the water
Is boiling. 100. Yeah. So this, let me write it down here. 660,000 will equal M C delta T. Now, can you look up the heat capacity of copper? I think it's something quite small, like 285. It's in the table I gave you. It's beside the water.
385.
385. Yep. What else has happened? Where else has this energy gone? Well, it's increased the water's temperature from X to 100. So that's 0.25 times 100 minus X times 4181. And finally, what's happened? The water has boiled into steam. Just so you know, in English, this expression, boil off, means to turn the water into steam. So, it's M, and then, Musharif, please, can you tell us the latent heat of vaporization? 2265 kilo. Alright. This equation, when we solve it, gives us X. This is a little bit messy. So what I'll do first, you see this one here, I'll take this and minus this. Just bring it to the left. So that's 660,000 minus 0.25 times 2265,000. That's 93750. 93750 equals 0.025 385 100 minus X plus 0.25 4181 100 minus X. Now what's in common here? Yeah, so what I'll do is I'll just take that out. And then I take this and divide it by that. So I end up with 100 minus X equals over 0.025 times 385 plus 0.25 times 4818. No, 4181, isn't it? Yeah. 88.87. So that means X is 100 minus 88.7. 11.1. That's the temperature the water and the copper was at the beginning. Now, this is again the type of question you get in the exam. It is a difficult one, but I hope you can see.
11.3
It does. I used the exact number on the calculator, so I got this. I hope you can see that even though it seems difficult, if you concentrate, it's not that bad actually. If you just be careful with your X's. What? Now what are you thinking? What? Huh? Alright, fine.
Can you zoom out?
How far?
Yeah, okay. Anyway,
Yes,
I have question.
I
If
know.
the-
Yes,
No,
what?
nothing down.
Yes?
If I have to, I can go to Trinity.
You'll have to make an independent application.
Yeah, but I want to ask you if it's better than the other.
Depends on the course, honestly. What course do you want to do?
Anything.
I don't know, Ms. Sharif. I don't think there's much difference between DIT and Trinity for mechanical engineering. I mean, you could try if you want, but for mechanical engineering, I think DIT is nice. The nice thing about DIT, because I've taught, I do private lessons, and I've given private lessons to students in DIT and Trinity and UCD, so I get a good feeling for what the lecturers are like, and my impression of DIT was very positive. It seems like the lecturers in engineering are very helpful with students, one guy was saying that he had this project he wanted to build, and the lecturer was saying, no problem, you come to my office, I'll give you the parts for free, It just, to me, it felt like a very positive environment. So I don't know. You might not get that in Trinity because Trinity is bigger. And I know you like to ask questions, so maybe you would prefer a smaller class. Whereas if you were in Trinity, you'll be in a class with 500.
Really?
For some classes, yeah.
500 students.
Well, if he's doing engineering, I'd imagine one of his classes in engineering will be a common class, something like maths for engineers. So there'd be civil engineers, electrical engineers, you know what I mean? So it'd be a big lecture hall of whatever, a couple of hundred people.
You can't ask any question.
Oh, definitely not. Definitely not.
No one will answer it.
I know, but
If
your classmates wouldn't appreciate it.
I study into 400 before.
Yeah.
So the only chance you can, if the whole class doesn't know anything. But if there's like 100, 10 there, 10 there, you just sit there.
Yeah. So
And
maybe-
not so you can understand what's next. So when you don't understand it, then
And that's it. So maybe, Ms. Sharif, you would prefer DIT. I think DIT is very good though.
yeah, but my sister
Your sister's a doctor.
like Trinity. She told me like half history and very good.
Do you care about history?
No, don't.
If you want to be engineering, it's more important that you're with lecturers who can help you in your career. So if they can help you with projects or give you advice or recommend you to businesses or, give you contact information, this is much more valuable than having a history in a school.
Yeah, but like in my country, they don't like if you have good knowledge. They only look at what is your interest, like. So they are Trinity, so you must be very smart. But in Trinity,
What do you want to do when you go back to Sudan?
apply in France?
You don't know?
No,
Maybe you want to stay in Ireland?
no,
No, definitely not.
yeah.
You never know. Things change. You just remember that when we see him in 10 years in an Irish company or something.
No, I might do master.
It's already started. And then after the master's, like, maybe I'll do a PhD, and then the next thing you know it's...
For a year to get experience.
Yes, yes.
To be sure I won't marry, and I...
Now you see, you say that now, but then maybe in 20 years' time, you see, and then you'll be thinking of us.
Little Musharraf running around.
That's it, that's it. As you're applying for your Irish passport.
No, I don't know.
My point is, you never know what's going to happen in the future. But me, I think DIT is very good. So it's what you prefer, you know. But Trinity is very difficult to get into. Very difficult. Do you have good high school results?
No, they say they can accept
Do they? IFY?
with 6.55.
And what's your IELTS now?
5.5.
Could you get 6.5? That's a lot.
Yeah.
You think you
I
can?
told her I can do like 6. But she told me like I'll make you stay here for a while to do course after we finish, like after May.
You'll do an IELTS course?
Yeah.
Yeah, probably like English.
Okay. I don't know. Don't forget, if you start in DIT and you get good grades in first year,
Can go.
you can possibly transfer. Because I had one student who wanted to go to DCU, you know, Dublin City University.
Is it better?
But it depends what you want to study. So DCU is better for business. DIT is better for engineering. Do you get what I'm saying? It's not like this one university is best for everything, you know. So she wanted to study to work in insurance, so she wanted to go to DCU. She didn't get DCU, so she went to Maynooth or something like this. And then after 1 year, she transferred to DCU.
But wouldn't that make visa problems or something?
I don't know, what's the time limit on your visa for university? I thought it was 5 years.
Yeah, I have 5 years.
Yeah, 5 years.
But you want to transfer to UK? I don't want. I want to stay here. That's why.
But 1 year and I'll
It's just another option, Ms. Sharif. If you don't get TCD, you could go to DIT and maybe you could transfer after 1 year. Once your grades are high enough. You know?
High enough like what?
depends on.
It depends. If you get an A, then there should be no problem.
Yeah, the GPA is out of 10 or 4.
Well, it's different, it's complicated. It's a bit like our IFY grades. You have A, B, C, D, except they call them different things.
No, but they do have like GPA for all of them. Like.
I know, but I don't know what the GPA is. I just know the grade letters. So if you get an A, it should be no problem. If you get a B, maybe they'll interview you.
In all of the courses, A,
Yeah.
A,
You mean like all the subjects? A
No, average.
total GPA.
Yeah. Because when I interviewed for, when I did my master's, I needed at least a B. Like, it's kind of like B is the minimum to transfer. That's the minimum grade. If you don't get a B, they won't even consider it.
Yeah, my brother is doing that. Okay, how can I get C and I fail?
C is no good.
Yeah, you fail if you want C. Only B.
Your options are gone at a C or a D in university. You need a B before you can do anything. And in Ireland as well, when you apply for jobs that require a degree, like, I don't know, if you want to work in a bank or something, and they say you must have a finance degree, again, they will only want you if your grade is at least a B. You know?
Really?
Yeah.
So if I went to the university and I just C, I'm not doing anything.
Not any
Yes.
for Ireland, yeah.
Anything.
Yeah. So if you want to transfer, keep your grades high. Yeah. Okay. Now, we have some questions here. Nice. I'll let you work on these now for a couple of minutes. Will I leave it on the screen, or do you want to open it on your phone? On the screen?
Help them thinking.
You can think about it by looking at it. Yeah. Okay, well let me just stop the recording here.